Alright everyone, welcome back to my channel. So today I'm gonna do a problem called house robber. So this one is a dynamic programming problem. It's simply just state that you have an array of numbers which represent a house. So if imagine you have this array of 1, 2, 3, and 1, right? If you choose this one right here, you add 1 into the result, but you cannot add the adjacent element into it. So it must be, if you choose 1 right here, you must jump to 3, or you got to do 1 right here, either way. So in this case, you don't choose 1, right? You choose 3, so you plus 3 right now, right? And then you can choose either, but when you choose 3, you cannot choose 1, so that is equal to 4, right? But for this kind of problem, you have to simply drawing a traverse like that will not gonna solve it. You have to draw a decision tree, right? So let me draw a decision tree right here. Let's say at the first stage, right, you have the option to choose 1 or not choose anything, right? So let's say when you are at, let's call this one is, you are at index 0, right? You have option to choose 0 or not choose index 0, right? This one is choose, no, yes, choose, right? If you choose the, let's do it like this, it's gonna be better. So you have 1, 2, 3, and 1, right? This is index 0, so you're right here. You have option to choose. If you're not choosing that, the totals right now, oh, should be like this. Right now the total is 0. If you're not choosing that, the total is keep being 0. But if you choose that, your totals right now is 1, but you can only move to, you have to jump to 3, right? So right now the total is 0. You have to choose 3 or not choose 3, right? So in here, you have the option to, you are at 2 right now, right? So you have the option to choose, not choose 2 or choose 2, right? So you have 2 more options right here. If you choose 2, your total is 2. If you not choose 2, total is still gonna be 0, and you move on. So right now you're at index 3. Right here you're at index 2, and you have an option to skip the, you have to skip the 3 right there. So you have to choose 1, right, or not choose 1, right? So if you not choose 1, it's 2. If you choose 1 right here, right, so it's 3, and here is same. Right now it's 4, and here's 1, right? So when you choose 3, you cannot choose anything else. You're out of bounds. Same thing for, you're not choosing 3, so you're at 1. You have another option, etc. Eventually this one will pop back up, and the only thing you need to do is to compare all of the chosen. If you choose or not choose, you have to compare. You have to return the maximum between the chosen one and the no choose one. So this is a brute force approach. Then after that, you can add a catch to solve it. So let me just try to run this for you to see, right? And then in the beginning, you will have your result here, right? So you have your DFS of I. Then if I is greater or equal to the length of nums, you return 0. So when it's outbound, you just return 0. In here, you just return the maximum of DFS. This is when you not choose, so DFS of 1, right? And then this is when you choose. So if you choose a current number, it's gonna be current number plus the DFS of I plus 2, right? So you have to jump twice. This is what you return, and at the beginning you can choose to start whatever you want to start. So length of num, right? So result would be equal to the max of result and the DFS of I, right? So at the end you just return result right here. This one is word, but it's not gonna pass the test case, so you're gonna need to add the catch in here, right? So just wait for it to run a little bit. See, so it's time limit exceed. This is not really efficiency. Time complexity for this is O of 2n, 2 to the power of n, so it's not really good. Because have 2 to the power of n, you have to loop through the length of the nums array too, so not efficiency. One thing you can do is you add a catch. So to add a catch, you just need to if I in catch, right? You return catch of I, and you just replace this with a catch she, and then in here you just return the catch, and it should work the same. Let's see, and it's gonna pass the case. However, this is just the top-down solution. There's gonna be also the bottom-up solution where you start at in this one you start at index 0 and then you go all the way to the end of the array every single time, because and then you have to do the choose or not choose this DFS in here. So this is the top-down. There's a bottom-up solution too, and we're gonna start say bottom-up, meaning that it starts from the base case. So we're gonna do the base case, right? Let me try to draw that out. See, so imagine you have an array, right? And oops, an array of 1 2 an array of just 20 items. Let's say it's just everything start with 0, like here, right? So we start at the end of this number. Yep, we start at the end. So in here we have to find out if this one, if we're gonna choose one or not, right? So, oh, my apologies. It should look like this. So use the second n elements are in the array. So you start from here. You ask if these and the one that is outside of the array, which is in arbitrarily 0, right? It just means that this is outbound, so it's gonna be 0. If these two is greater, if I put 1 in there, that is not really correct, but just trust me, this is 0, right? So I put 1 2 3 1, right? There's 0. So if 3, right, plus with the 0 outside is greater than this 1, right? So in here, since 3 is greater, so we put 3 in here. So we know that of this 3, we know exactly that this one is the from this position, this is the graded profit, that the most biggest profit. So this is 3 right here, and then we move on to this part, right? We ask ourselves, we got 1 right here, 2 plus 1 is 3, and we have 3, right? So this one is obviously it's gonna be a 3, right? We know that at this point 3 is the greatest, right? And then we move on to this one. So if you choose this one plus this one, it's gonna be 4, or we choose this one right here, 3. So 4 is greater than 3, so we put 4 in here, right? It's just meaning that, yep, remove this, and then we just return this one. It means that from this point, right, 4 is the greatest. However, since you don't even need this array, you just need 2 variables, right? So variable, you don't even need these 2 array, you just need 2 variable, right? So let's remove this, and we put the previous as 0, right? And the current as 1, right? So we start from this point. We start with right here. We start at this point, right? We ask, if this point plus my previous is greater than my current, right? My current right now is 1. So if it's greater, we update our current as equal to 3, right? So we move this. Basically we move this current to here, right? Let's remove this. How did I move this? So my current is right here, and my previous will be moved to 1 right here, and then we continue. This 2 right here, 2 plus my previous is 3. Current is 3, so right now current is gonna be 3, right? Current is 3, so let's put 3 right here. Let's put 3, and we move our boy previous to here, right? Same thing at this point. 1 plus 3 is 4. My current is 3, so absolutely 4 is gonna be the biggest, and we just move our current to the biggest. So our current here, our previous here. So we just return our current. So we just need 2 variables. We don't even need an array. It bring our space complexity to all of 1. All right, so let's try to code this up. So we have our thing right here, and then this one is absolutely, when you can code this up, this one absolutely will help you a lot with the bottom-up solution. So So I have the current, right, and the previous, and I have my one, right, the last variable, the one, and 0 is the one that is outside. So we're going backwards. So in range of length -2, right, -1, and then I have my temp value to hold my current, right. So I update my current right here. So my current would be equal to the previous, to the max, right? We have to choose between the current and the max. Oh, my bad. Max of the current and the numbers at this, not current position, but at this I position plus my previous, right? And then we just update our previous equal to temp. And here we return R1. We return the current. Right, so it should work. Yep, work perfectly, and it passed the case. So if you like the solution, please give it and subscribe for the channel. Help us a lot. See you soon on the next video.